today I want to define a relation and some terms that go along with this term, and then look at some examples and highlight all these different terms in that. Okay, so first of all, we define a relation to be just simply a set of ordered pairs. All right, now the thing is that the first coordinate in these, for each one of these pairs, ordered pairs, is related to the second coordinate, and that's why we call it a relation. Now for the domain, we mean the set of all those first coordinates. And then for the range, we mean all of the second coordinates. And so typically, the way we think about these is the first coordinate, we usually call it an x. It doesn't have to be an x, but that's like an input. And then the y coordinate associated with that is called our output. So the domain is like the set of all inputs, and the range is like the set of all outputs. Now also, a function is a special kind of relation in which every element of the domain is paired with exactly one element of the range. Okay, so what that means is that if you have two coordinates that have the same input, then your relation is not a function. Okay, so I have some examples here I want to look at, and we're going to highlight the domain and range, and we're going to try to figure out, are these functions as well? So for the first one, in A, I just have a set of coordinates, 1, 0, -2, 1, 3, 0, and 1, -4. So first of all, this is a relation because it's just a set of ordered pairs. If I want to look at the domain, remember the domain is just simply the set of inputs. So my inputs are, well, I have a 1, a -2, a 3, and a 1 again. I don't need to put that twice. And for the range, that's the set of outputs. I have 0, 1, 0 again, and -4. Okay, now, is this a function? And the answer is no. Now why would that be? Well, sometimes students say, well, no, it's not a function because look, the 0 coordinate shows up twice. But that doesn't really violate the rule of a function. Remember, the rule of the function says that one input can't have more than one output. So in this case, notice that the 1 is an input for two different points with two different outputs. So no, this is not a function because of 1, 0 and 1, -4. Okay, so let's look at B part and let's look at the same thing. Is this a function? All right, so here's my domain. The set of inputs, again, is going to be 1, -2, -4, and 2. The range is simply, again, the set of outputs. So that's 1, 3. 3 shows up twice, and then 0. Okay, now we ask ourselves, is this a function? And this time, yeah, the 3 shows up twice, but remember those are outputs, so that's not really important. This is a function. Every input has a distinct y coordinate associated with it. Okay, every input has exactly one output, and that's the definition of a function. Okay, now I'm going to look at a couple of more of these that are not necessarily numeric to show you that relations and functions do occur in the real life. Okay, so here for part C, I have, the way you read this is the set of all coordinates x and y that have this property, x eats y. X eats y. Okay, so here we don't actually have a list of what's in this function or this relation, but let's think of some things. Okay, so for example, I eat chicken. Okay. Dogs eat chicken as well. Right, but chicken eats something, right? Chicken eats corn, and we can keep going down this list indefinitely. Okay, so the domain here, well, we don't really specify. I guess it depends on what we mean, but I'm going to say, how about all living organisms, all living things? And you may want to exclude plants, but we can get down on the biology of that at another time. The range would be all food sources, right? Okay, so that's very, very broad. This relation is very large. Now the question is this a function? And so remember, the function is that one input goes to one output. Every input has its own output. So here I think we'd say no, it's not a function. Can you give me an example why? Well, how about an alligator can eat fish, and alligators can also eat turtles, and alligators can also eat alligators and humans and anything that falls in the river, really. Okay, so this is not a function for that reason. Alright, so let's look at the next one. It says here, this time we have the set of coordinates x, y, where menu item x costs y dollars. Menu item x costs y dollars. So I think the understanding here is that we're at a restaurant, a specific restaurant. So if that's the case, then my domain would have to be menu items. And my range, it's hard to say exactly, but it'd be least price to greatest. So the cheapest thing on the menu to the greatest, the most expensive thing on the menu. Okay, and so some examples of these, of what would look like, what we'd see in this relation would be something like this. How about the pizza cost $13, right? So it's a 13, pizza 13. And how about a drink, $2.50, and so on. So we go down the menu and just price it like that. Okay, now is this a function? I'm going to say yes. I know we're going to ignore like market value prices or the difference between a lunch and a dinner menu. We're just looking at one menu. Yes, every item has one price. So there's an example of a function. Now functions in particular can be very, very powerful in mathematics because the idea is, again, you have one input that's associated with one output. And there are different ways to visualize this idea. So I kind of want to run through those real quick. The first idea is what I call the machine idea, the machine picture. And so you can imagine that this function is some sort of big machine here, and you put in something, you put in your input, and then out comes something else, an output. So for example, you may put in the number 3, and out comes the number 6, or something like that. I don't know, depending on what your function is. But again, it's a machine. So you think like a vending machine. You put in your quarters, and out comes your cookies. Okay, the second way to visualize this, and I think this, so the machine idea is a good way just to talk about what a function is. The set idea helps you visualize it a little better. And the idea here is that you have two sets. One set is your domain, that's your starting point, and your second set is your range. And so the function would take, for example, you may put in 3, and the function actually maps this over into the range to the value 6. So you start off with 3, you end with 6, and so your function is what carries that over. And in this idea, you can easily see that if you had, for example, 3 and it carries over to a second value, let's say 11, for example, then this is not a function anymore because you have one input going to two outputs. And so the set concept, the set picture really helps clarify that. The third way to do this is through graphing. Okay, and so this is just your standard XY coordinates. And so if I put in a value of 3 in the X direction, then in the Y direction I get the coordinate 6. So 3, 6. That shows you the relationship, the relation with a relationship of 3 to 6. Okay, so the function, if you collected all your points together, you may end up something like this. Okay, and any point along here has an input associated with it and an output. So this graph idea makes me think of something else. What if I had a function that did something like this? Okay, so is that a big deal? Well, think about this. If I took this input here in my x, that gives me that point, but it also gives me that point. And let's just say, just for hypothetical, let's say this is a -1. So here I have a coordinate that has a -1, some output, and I have another one over here that's -1, some output. And though since this example is generic, I don't know exactly what those outputs are, but what I do know, let's call that one A and B. What I do know is that A is not B. So what that means is, if you come back to the machine concept, I plugged in a -1 and out came A and B. Or in the set idea, I plugged in -1 and out came two things, an A and a B. That's not a function. That's not a function. That can't happen. So if I have a graph and if I can draw a vertical line that cuts the graph more than once, hits the graph more than once, that cannot be a function because I have one x coordinate associated with multiple y coordinates. All right, now this idea is called the vertical line test. So the vertical line test says that if you have a function graphed in the xy plane, we call that the Cartesian plane, and you can find a vertical line that cuts this graph more than once, then your graph is not a function. And the idea, again, I think is very clear because there's one input associated with multiple outputs. All right, so this is the basic idea of a relation and inputs, outputs, domains, and ranges, and in particular functions. And there's a lot you can do with functions. They're very useful. And so these concepts are very important to understanding the basics of algebra. I hope this makes sense. If you have any questions on these, please let me know. Don't hesitate to ask. I'd be glad to help. And thank you for watching.